Let's get started. So we are going to talk about development data sets today. But before we get started, just want to do a reminder about the environment. We have lots of training materials for you to review when you have time or when you have a question. You can find some of our stuff in the Portal Training Hub or in Code Commons. And we have practice data that doesn't include PHI, PII in our CDR PSA community schema. And if you look here, you've got a whole bunch of links. This one takes you to Portal. This takes you to the Training Hub. You've got news and events down here. This leads to Code Commons, where we store all of our code. And then you've got the PSA community workspace, where we have all of the notebooks that we use in our presentations. And you can see here's an office hour example, an interactive session example, and our learning path. And then finally, we have our schema. And if you go to this notebook and you go to the links, you'll see this stuff. Awesome. So what we're doing today is we are talking about how to create development data sets. And what our objectives are is to talk about why they matter, how they enhance performance, how they're useful for safety, governance, and compliance reasons, and also strategies for creating useful dev subsets. So the first question is, why would we do this? And there's a lot of reasons. In general, using production data is risky, especially so when you're doing development. And that's because when you're creating custom code that's new, it's very easy to do an accidental edit or delete of some sort. And it's easy to put a wrong table into an override statement, and then you need to rerun a whole time-consuming process. Highly problematic. It's less of a problem when you're using established code because you've already run it before. You're not going to mess anything up. But it's very easy to mess up production data when you're working with development stuff. So when you're working with development code, you want development data sets. Second reason is if you make schema changes to production files without testing first, that's a good way to lead to broken pipelines, ETL processes. You never know when you have a field that you think is useless, but is actually used in something that comes up later. And you might find out that maybe you think that adding a field might be a good idea, only to find out you changed the schema and now your ETL process is broken. If you do testing and development first, then you won't have these issues. Another issue is that development code is usually developmental. And by that, I mean you're creating things and you can always have something that you think is going to work great and it doesn't. It takes much longer than you would think. And if you're working with production data and that happens, it's very easy to run something that you think is going to take 5 minutes and that's taking 5 hours. And if you're doing testing, that's a big problem because that means you'll lose half a day. If multiple people are using production data sets to develop programs, one person can easily do something that messes up data sets for other people that are doing their things. And if they each have their own specific data set, development data set, then they don't need to worry about that. In the CDR environment specifically, we've got a lot of large data that has a lot of PHI, PII. And that means using it to create new workflows and notebooks. It has significant time, costs, and savings implications. And again, unlike SAS, Databricks charges based on the amounts that your programs take up. So if you run some code that's very inefficient, Databricks charges for that. In SAS, it didn't really matter. In Databricks, it does, and the help desk is monitoring total spend time, trying to make sure that we are being cost effective. And all these are good reasons why it's a better strategy that instead of using production data has everything, use a smaller data set that's designed to be fungible that has fewer things. And that way, if that table gets deleted, it's easy enough to recreate. If you're running code, it's easy enough to create something. And things basically just run faster. So as your general strategy for development, what you want to do is when you're first creating a new process, you want to use a development data set. And that's going to be a data set that's smaller than production. And that way it allows your developmental code to run faster. That enables you to fail fast and also requires less compute. And at this point, you would want to run your code via all-purpose clusters. That way you can make changes quickly. Once you finish your program and you've got things you think are working on your development stuff, you want to start moving your notebooks instead of running on all-purpose cluster to run on a job cluster. And that way you can schedule the code, and that way it costs less. So it's going to be you're a good steward of costs. And also, when you run things only when you think it's going to work, it's going to help you do your testing. It's going to help your testing run faster. And once you've done that, once you have it scheduled to run on a job cluster, that's when you should start using the full set of data. And then once your process is successfully running, it's past QC, that's when you should start using production data. So only when you're relatively comfortable with the results of your stuff working on a full set of development data, that's when you start using production data. And that's at that point, your process should be largely put in stone. You're not expecting to make any changes at that point. And that way you can be comfortable that your production data will remain safe. Okay, so we've talked about why we should create the development of subsets. How can we do it? And some strategies are random sampling, stratified sampling, time window sampling, schema-only datasets, synthetic data generation, and feature-level subsetting. So random sampling is exactly as it sounds. It allows you to grab a random amount of data. It comes in handy when you have a large data set, you don't know much about it, and it's huge, and it may be 10 million records. If it's going to take you hours to run anything on it, you don't really know much about it, and you want to learn about it. So instead of analyzing all 10 million records, you might look at 10,000. And that way, whatever you run, it's going to run quickly. It also comes in handy when you just want to look at the first X records of a data set for QC purposes, just to make sure things look right. So that's like instead of doing a print for 20 for n obs equals 20, the idea here is you just look at the first 20 records, you make sure that they all look okay, and then you go on. And there it can be random because you don't really care which records you get. So the first way you can do this is by doing a limit command. And this gives you just the first X amount of records. And this is allowed, you can do this in Spark, you can do that in Databricks SQL. The second one you can do in Spark is a command called sample. And that allows you to get a basic sample of your data set, and it allows you to specify whether you want rows to be sampled twice, specify the percentage of the data set you want to use, and lets you create a seed so you can regenerate this exact sample. Databricks SQL has something similar called table sample. Okay, so let's look at some code. So here we are working with the Titanic training data set. And you can see this data set, you can see it has about 900 records. When I do a limit, I can just do it like this. So I'm reading it in that table. I put in limit was 100, and I do a count, getting 100 records. And I don't know which 100 records I'm getting. I mean, presumably it's the first 100, but who knows how it's Spark, so who knows what 100 they pick as first. But I'm getting 100 records, and I could change this to 50, I could change it to 10, I can change it to whatever I want. It's going to get me a specific X amount of records. But what I can also do is sample. And what this code is going to do is to get me about 10% of data. What it lets me to do is it lets me to get roughly a percentage of the data, and then it gives me a few other options. It gives me the with replacement option. That is default false, and that means that rows can't be repeated. If I were to set that to true, then it would say that a row can be repeated. It gives you the fraction, and that lets you specify the percentage that you want to get. And then it gives you something called the seed. And this, if I put in a seed, I will get those records back each time. And that's helpful when, I want 10% of the data. I don't care which 10% I get, but I do want to get the same 10% each time so I can rerun code in the same sample instead of, having to start over and, maybe I get a different sample, or else I have to save it to a table or something. I do this, and I can get the same thing every time. You don't need to do anything as complicated as I did before. This code right here gets rid of the ref replacement name. It gets rid of the fraction name, the C name, and I can just run it like this also. And you can see I got 95 records. My data set was 891. You can see it's closer to like 10.5% of the data that I got, which, I mean, that's fair enough, right? It's not going to get you exactly 10%. It'll get you something in the ballpark. So for Databricks SQL, we have something similar called table sample. And you can choose one of three ways to get the sample. You can use either percentage, num rows, or the bucket. And also you can put in a seed here. Keep in mind, if you do num rows, that it is not a simple random sample. It's just give you, it's going to implement it via a limit. So it will give you the first 100. It's not going to be fully random. If you want random, you do need to use either num rows, or you need to use you don't use num rows. You use percentage, and that way it will give you a certain percent. And it is not going to support things like where clauses. And here's an example of how you do it. I'm taking my training data set that is in PSA community. I'm doing a table sample. I'm specifying I want 10% of the data. I'm specifying I want repeatable, and I am putting in the seed number of 1, 2, 3, 4, 5. And I got 95 records. That is the same seed as above. And if you look at the data, you can see that this data and that data are the same. Okay. Next up is stratified sampling. And this allows you to divide data into subgroups called strata based on characteristics that they share. And you can choose things like age groups, disease types, risk categories, whether a member is part of Medicare, Medicare Advantage, so on and so forth. In Spark, you use sample by to do this. And sample by, the basic format is right here, where you have col, fractions, and seed, which is optional. So the col is the column you want to use to split your data set. The fractions is going to be the sampling fraction for each stratum. If it's not specified, we treat its fraction as 0. And this comes in handy for something like beneficiary partition, where you have thousands of them. Maybe you only want a few of them, so you could specify like 3 or 4, so you have to write out all thousands or so. And then there is seed again, which is optional, but it allows you to recreate the sample you're using for future use. And here you can see a sample of this, an example of this. Here I'm using my Titanic training data set again. I am using survive to partition this sample. And I am saying that if the value of survived is 1, I want 0.1% of the data. And if it's 0, I want also 0.1. So 10% each way. And you can see here, I got 90. So this seed got me a different result. I got different numbers. So you'll get, not only will you'll get something close to 10%, but what that percent is might vary each time, depending on your seed. And you can see I have a data set. If you want, you can get tricky. And what you can do is you can merge columns together to use multiple columns. And here, for example, I want to do it on survived in P class. Well, I can't do 2 columns in sample by, but I can merge these 2 columns together. And you can see I merged them together. You can see now I have P class first. P class has values from 1, 2, and 3. So you can see I have these 3 values. Survive has 0 and 1. So you can have 6 values total. I have different fractions set to each of them. And now I'm doing my sample by. I do it by my survive P class field. I set fraction equal to my list over here. I do seed equals 24. And voila, I have another data set. And I have 122 rows because I did something different. I did different fractions. And I have my sample data set. Next up is time window sampling. The idea here is you can do the last X days, months, or years of data. And that way you can be sure you gain a representative sample of data, but still limit the data that goes through the system. This can fail if things change from day to day, month to month, or year to year. So be careful about that. But in general, like when you're working with, if you're working with claims data, this is very useful. And again, when you're working with claims data, it's recommended to use only 1 year's worth of data at a time. And in development, you really only want to use 1 month's worth. And then once your testing is complete, then you can start turning your stuff into a job. You can start using 1 year's worth of data. And here we're going to use the customers table. I got about 800 records. And here I am going to do a filter. I'm going to do it on the date that the customer account was created. I'm going to say I want everything that is earlier than 2017 in September. And sure enough, I get my records, and you can see everything is less than that date. Next up is schema-only datasets. These datasets just have schema, no records in them. It's useful for ETL processes. Basically, the idea is you can use these to make sure you have the right columns in your table. And then once you have the right columns in your table, you make sure you have everything you want. That's when you can start adding the data in. It's just useful just to structure data up front, to do quality control checks, stand in and place pipeline placeholders, things like that. And here's an example of how you can do that. Here we're defining a schema, and then we just create an empty data frame, and we define it using the schema defined up here. And here we're doing a show, and you can see it's just a basic empty schema. Another strategy you can use is synthetic data generation. And this generates fake data when you don't want to use real data. And if you do it correctly, you can substitute this data for sensitive data such as PII, PHI without a loss in performance. And the methods used for this are Spark.range and Faker. And where this really comes in handy is when you want to replicate beneficiary data. Because you don't want to use normal beneficiaries when you're just developing things, right? Because then you're using reproducible data. And I mean, it's a security risk. So if you use something like Faker and Spark.range, you can create fake data instead. And that way you're not putting other people's data at risk for things. And here's an example of how you can use Spark.range. Here I'm using the Spark.range method. I'm just creating 10 records. And it is going to create me a data set that just has 10 records. It has an ID field, and now I have 0 through 9. And the reason why I'm using that show here, if I was actually going to manipulate this data, I would use a display. I'm using that show because it's a small amount of data, and I just want to see a printed copy of it. Fine. And so the next thing we can use is Faker. And Faker is used to create fake data. And in conjunction with the Lambda statement, it can be used to create fake data sets. And the idea is you want to create small data sets of Faker, and then you want to just join them together to avoid worrying about non-random data. So what you want to do is you don't want to create just a data set that has 1 million records. You would rather create 100 data sets that have 10,000, do them all randomly, and then join them together, and then you should be good. And Faker can do a whole lot of stuff. It can generate fake personal information, contact information, financial info, dates, random tests, and plenty more. There's a lot of things that you can do with it. And there's a link below at the end of this presentation if you want to learn more. But you can do a lot of things with Faker. So the first thing to do to get Faker working is to install it. And here we do a pip install Faker, and that gets it installed on our cluster. And now here is basic usage. So first you need to actually import the module and then the library. And then what you want to do is you want to use it in a in an instance. And then what you're going to do is you can print things. So here we are printing out a random name, a random address, a random email, a random date of birth, and we get random results as you can see below. And you can see we have Nicole David Thomas as our random name. You've got an address for her. You've got an email. You've got a date of birth. Great. You can also use a seed. And by doing that, I can get the same random fake data every time. And that's helpful when I don't care what the data is, but I want to make sure I get the same thing. So when I use this fake and I print this fake.name, it is always going to give me Allison Hill. And this shows how you can use Faker to create a data set. And here we have, here we have the modules you need, a UDF, a string type, a fake, and then Faker again. And then here we're just creating the UDS, so fake names and fake addresses. We have n equal to 1,000. We're going to do a spark.range. We're going to use that for name. We're going to add a column address. And then here's what 500 records look like. And this data set would have 1,000 records in it. Another strategy you can use is column level subsetting. And the idea here is that instead of reducing rows, you're going to just get rid of columns. And the idea is just grab the fields that you need. So when you are creating development data sets, you don't want to make them just smaller, you also want to make them safer. And the way you can do that is by masking PII, PHI, and spend data in these development data sets. And outside the scope of this lecture, we don't have time, but the things that you can use for that are row filters, column masks, and column tags. And if you want to learn more, you can see those links. Another strategy used for development data sets is deep clone versus shallow clone. So there are 3 ways you can create backups. The first is create table as select star, CTAS. And the idea is you're taking data, you're physically moving it from one location to another. It's expensive, and it's not going to preserve history, metadata, or column restraints. The second thing you do is a deep clone, and that's going to copy the metadata plus all the data files from one location to another location. And that new table is independent of the old table, and it works as a full backup. And there's also a shallow clone. It's just going to take the metadata. It's going to use the data files from the source table, and that goes a lot quicker. It preserves history, metadata, and column restraints. But if your base table gets deleted, your shallow clone breaks. Both shallow and deep clones have a place in the dev environment. Shallow clones are useful for short-term development data. That's where you're using something for a day or two. And the idea there is you can update shallow clone data without impacting the parent. And if the parent changes, the shallow clone breaks, but it's something you can use if you're only going to do something for a day or two. 5 people want to do something, you create your own shallow clone, and you're good to go. Deep clone is useful for more long-term development data and backups. And that's where you want to say something for a few months. You want to make sure you have a backup somewhere. And the idea where this really comes in handy is where you've done something to the table, like you've done masking, you've done tagging, and you don't want to have to recreate it. So you do a deep clone, and then you have it all in that backup automatically. Primarily, this stuff works with Delta, can work with Iceberg and Parquet. And down here, you can see some examples of how you would do it. This is an example of a deep clone. And here you've got a shallow clone example. And here you've got a shallow clone example in Python. All right, so just to conclude this, at the end of this lunch and learn, you should have a better idea of why to create development data sets and strategies to create them. And here at the bottom is a bunch of links if you want to learn more.